Namaste, this is Maulya, studying in Sri Venkateshwara College of Engineering, Bangalore from the Department of Computer Science and Artificial Intelligence. Today I'm going to discuss about the topic clustering, which comes under the subject Advanced Artificial Intelligence and Machine Learning. Clustering is a pattern in data. Welcome to this exploration of clustering, a powerful data analysis technique for grouping similar data points into a meaningful cluster. This presentation, it will introduce you to the fundamental of clustering, delve into various algorithms and guide you through evaluating their performance. We will also touch upon the importance of dimensionality reduction in optimizing the clustering process. Join me as uncover the fascinating world of clustering and learn how it will reveal hidden pattern and insight of your data. So what is clustering? Clustering falls under unsupervised learning, meaning it doesn't require labeled data. It discovers hidden patterns and structure within the data without prior knowledge of the groups. Think of it as finding the natural group within a dataset. Grouping similar data means clustering aim to group similar data points together based on their characteristics. These characteristics can be anything from a customer demographics to product features, allowing you to segment data based on similarities. The importance of clustering. Customer segmentation divide customer into distinct groups based on their purchasing habits, demographics or preference. This allows for targeted marketing and personalized experience. Anomaly detection identifying unusual data points that deviate significantly from the rest of the data. These anomalies can indicate fraud, system errors or other important events. Next comes the image segmentation. Group pixel in an image based on their color, texture, or other visual features. This can be used for image recognition, object detection, and image compression. Next comes the another importance of clustering, that is pattern discovery. Here are some types of clustering algorithm. Partitioning, k-means, k-medoids, and fuzzy k-means falls under partitioning algorithm. They partition the data points into predefined number of clusters. Hierarchical algorithms create a nested structure of cluster. They can be agglomerative, that is bottom up, and divisive, that is top bottom algorithm. Density based. These are all the density based algorithms that cluster data points based on their density. They are good for identifying cluster for varying shapes. Model based algorithms assume a probability distribution for each cluster and estimate the parameters to fit the data. K means clustering. Iterative algorithm. K means is an alternative algorithm that starts with the initial set of centroids and repeatedly assigns data points to the closest centroid, recalculating the centroid based on assigned points. Predefined number of cluster. You need to specify the number of cluster K before running the algorithm. Choosing the optimal K is crucial for accurate clustering. Euclidean distance. K means typically uses Euclidean distance to measure the distance between the data points. Next, moving on to the hierarchical clustering. First comes the agglomerative. It starts with the data point as a separate cluster. It iteratively merges the closest cluster until a single cluster is formed. Dendrogram, the result are visualized in a dendrogram, a tree-like diagram showing the hierarchy of clusters. Divisive, it starts with all data points in a single cluster. It iteratively divides the cluster into smaller cluster until each data point is in its own cluster. DBSCAN clustering, density-based approach. DBSCAN density means density-based spatial clustering of application with noise. Identifies the clusters by finding areas of high density in the data. Core points, the data points with a minimum number of neighbors with a specialized radius are considered core points. This forms the center of cluster. Outliner detection is the another DBSCN clustering. The right clustering algorithm includes data structure. Consider the shape, size, and density of cluster in your data. Some algorithms are more suited to specified data structure. Outlier sensitivity assess how much your data contains outliers, as some algorithms are more sensitive to noise than others. Performance requirement, consider the size of your dataset and computational complexity of different algorithms to ensure efficient performance. Moving on to the last step, that is business goals. Let's align your choice of algorithm with your specified goal, such as customer segmentation. Clustering evaluation metrics measures how similar data points is in its own cluster compared to other cluster. A score closer to 1 indicating the good cluster. Measures the ratio of the minimum inter-cluster distance to the maximum intra-cluster distance. A higher done index implies better separation of cluster. And the last one is Calency-Harbus index evaluates the ratio between the cluster variation and the cluster variance. In this slide, you can note down about the high dimension PCA and improved performance, that is dimensional reduction for cluster. Please do like the video. Thank you.